Well, welcome to your next lesson in math. Today we're going to create equivalent fractions, and it is really kind of a fun thing to do. You take fractions that look like this and turn them into something else. They actually name the same amount, but they have different numerators and denominators. And here's an example. We're going to take that circle, cut it in half. We're going to turn it into 2/4. Watch this. Notice I've got two 1/4 sections of this circle. Okay, 2 1/4 is 2/4. It's the same exact amount as the 1/2. Let me show you again in another way. Starting out with these rectangles, all cut into half, light blue and dark blue. But I'm going to take the other two and I'm going to cut them up into different size numbers of pieces. And that's where the equivalent or the different fractions come from. Okay, so now the second rectangle, what I've done here is cut each of the halves into two. So I've now got 4 pieces of the same rectangle. So that means I've got 2 in the light blue, 4 all together. That gives us that 2/4 that we just saw a minute ago. Now what happens if I cut my rectangle up into 6 pieces? Well, I've got 3 in the light blue, and I have 6 all together. So all 3 of those are equivalent fractions. They all represent 1/2, but with different numerators and denominators. Let's see that with some other ones. Here's another one. Look at this one. I'm going to cut this one up into 8 pieces total. So you can count the blue on the top, the light blue. That's 4 of them. And a denominator is the total number of pieces. Okay? So it's equivalent. 4/8 is equivalent to 1/2. And here I'm going to cut it up into 10 pieces altogether. All right, and that gives us 5/10 is exactly the same thing as 1/2. Pretty cool, huh? We're just splitting it up into smaller pieces. Kind of like that joke we had in class recently about the person who wanted a pizza and didn't want to cut them to 12 pieces. And they didn't make sense to them that 6 pieces of the same pizza were the same amount. It doesn't matter if you eat 12 pieces or 6 pieces when you're only talking about one pizza. A little nuts, right? Now that's exactly what we're doing with equivalent fractions. So here's the example again. Take our 1/2 of our circle or pizza here, cut it in half again and again. Now we've got 8 pieces all together. 4 of them are in the light blue, and there's 8 altogether, so 4/8. Exactly the same thing. What happens though if we've got 3 out of the 4 colored in light blue, and then we cut it up like that? All right, now how many of the light blue? Well, count them up. I hope you got 6. And the denominator is 8 because that's how many pieces it was cut up in. All right, here's another example. We've got it cut up into 3 pieces, our circle. 2 of the 3 are in the light blue, but what happens if we cut up our circle into some more pieces? Now how many do we have? We have 6 altogether. How many are in the light blue? There are 4. So as you can see, we're not changing our amounts. We're just changing how we represent it. We're cutting it up into more pieces. Do you notice something here too? There's something common going on here. The 2 goes into a 4 and the 3 goes into a 6. Are you starting to catch on that if we just take the number 2 in this case, multiply that times 2, trying to make one here, times 2, and times 2, we get 4 and 6. So we don't have to necessarily draw this. And that's going to come in handy a little bit later. All right, so now let's guess what the missing numbers are. Can you take a guess? In the middle here, how many are equivalent to 1/2? You count it, either counted or multiplied by 2. And there we go. All right, it is 2 pieces are in the light blue. 2/4 is equivalent to 1/2. How about here? We've got 3 out of how many? 6. Not bad. All right, next one. 4 are light blue out of how many? Well, if we multiply this times 4 to get 4, multiply 2 times 4, and we get just how that works together. Same deal on the last one. What's our missing numerator? Count up those light blues. And it is 5. 5 out of 10. All right. Now, here's one for you. What's our missing numerator? Okay, number 2. Your turn again. This time, give me the denominator. Okay, here you go. Another one for you to try. And this time we're missing our numerator again. Okay, so sometimes it's not practical to draw pictures all the time, right? So this is how I want to show you now how to do it. This is actually the way we will do it from now on. But I want to show you that we multiply the numerator and denominator by the same number in order to get an equivalent fraction. Now, and the reason we want to do it this way instead of drawing pictures, you're going to start getting some bigger denominators, and you just can't draw rectangles and pies when you've got like 36 pieces in it. It just doesn't, work well. So if we multiply the top and the bottom by the same number, we come up with an equivalent fraction. Okay, 3/9 is equivalent to 1/3. And why does this work? Well, I'll tell you that in a minute. We also, remember we talked about simplifying before, we can do the opposite. Divide a number by the same number. 4 and 12, 4 twelfths. Divide them both by 4 and come up with an equivalent fraction of 1/3. Okay, so it can go both ways to come up with equivalent fractions. This is what we do when we're simplifying fractions. So, to make an equivalent fraction, you can multiply the numerator and denominator by the same number. You've got a new fraction with some values, the same value as the original fraction. It's the same value. You saw that with all the circles and rectangles. We're not really changing the value. We're not changing the value at all because all we're doing is multiplying it by 1. So what happens when you multiply a number by 1? You just get that number again, right? I mean, I can give you any number. If I say multiply by 1, you can just tell me that number, right? You don't have to get out the calculator. Well, here in fractions, having a number and the denominator the same is 1. It is simply 1. So 2 over 2, 5 over 5, 33 over 33, 1,500 over 1,500. It doesn't matter. That is just 1. So we're not changing its value. And this is a huge thing. So what do you get when you multiply a fraction by 1? You get the equivalent fraction. And we're going to find out very soon that that's what we need to do in order to add and subtract fractions well and easily. Okay? So let's take a look at a few of these. We've got 3/5 here. And I'm going to change it to an equivalent fraction by multiplying it by 4 over 4, which equals 1. It becomes 12 over 20. Okay, 12 over 20. Notice, I've also got some boxes to show you. All right, 3/5. Here's a pretty much a square, right? It's probably more, it looks like a square. But anyway, 3 out of the 5 are colored in. So over here, we just then cut it up some more so that we cut it up into 4 more pieces. So now we have 20. If you counted all this, there's 20 boxes, right? 4 by 5. Only 12 of them are colored in. But it's the same exact space as this one over here. Okay? So 3/5 is equal to 12 20ths. They represent the same amount. Okay? Here's another example. 2/3 and 3/3. All right? 2/3 times 3/3. This is just a 1. Right? It equals 6/9. And here another example, another box. 2 out of the 3. Same area colored. 2 out of the 3, but we cut it up some more. So this whole box is 9. So 2/3 is equal to 6/9. They represent the same amount. All right, so let's see what happens here. Without having to draw the boxes, let's find the equivalent the equivalent fraction by finding the missing numerator. We've got a denominator. What happened to this 3 to turn it into a 9? What number did I multiply the 3 to get a 9? What's missing? Well, 6 is what's missing. How did I get that? I multiplied it by 3. Okay? To get the 3 to turn into a 9, I multiply by 3. I do the same thing to the top. If I do the same thing to the top, I'm not changing the value. Okay? So now we've got it again, missing numerator. It's up to you to figure this one out. Okay, another one for you. Can you find that missing denominator? All right, now this one is totally up to you. I want an equivalent fraction for 5/12. You get to pick the fraction that you multiply by. And I want you, I feel like I have a spider on me. I just killed one a minute ago before the video started. So now I feel like it's on me but it's dead. Okay, so anyway, you have to come up with 5/12. Pick something. I don't care what you choose. Everybody can have a different answer for this and still be right. Okay? Pick a number that you want to multiply by and give me the equivalent fraction. Remember, multiply the numerator and the denominator, but with the same number. And you can't go wrong. Okay, enough spiders. I think I'm all cleaned up. We have attempted to practice and learn about visually equivalent fractions. I hope that helped you to understand a little bit better of how we're doing this. Next time you're going to need this knowledge because we're going to add and subtract fractions that don't have the same kind of denominators. So we need to know how to create equivalent ones so that we can make them equivalent so we can add the numerators. But we'll get into that next time. Have a good day and thanks for watching.